Hello, everyone, buckle up, because today we're diving into an epic adventure, one that's been shaking the Earth for millions of years: earthquakes. Picture this: nearly 2,000 years ago, in the year 132 CE, a brilliant Chinese inventor named Zhang Heng struts into the Han Dynasty court. Holding, what's this? A massive vase. Not just any vase, mind you, he tells the stunned officials. This bad boy can detect an earthquake anywhere in the kingdom and point us where to send help. Crazy, right? The court's like, Zhang, you sure about this? They're rolling their eyes, sipping their tea, thinking it's some wild gimmick. But then, on a perfectly calm afternoon, that vase starts trembling. Everyone's laughing. Oh, Zhang's vase is just having a moment. Until, boom, a few days later, messengers come sprinting in, panting, help, the ground just went nuts. Suddenly, those smirks turned to jaw-dropping gratitude. Zhang Heng wasn't just a genius, he was a seismic superhero. Fast forward to today, no more vases. Sadly, but earthquakes. Oh, they're still the sneakiest tricksters around. So, why are these ground-shaking rebels so darn hard to predict? And how can we outsmart them? Let's dig in, literally. Imagine the Earth as a giant, cracked puzzle. Its outer shell, the crust, isn't one solid piece, it's split into massive, jagged chunks called tectonic plates. These rocky titans aren't chilling, they're floating on a sizzling, gooey layer of molten rock deep below, called the mantle, and they move, super slow, like 1 to 20 centimeters a year. That's, what, the speed of a snail on vacation. But don't be fooled, those tiny shifts pack a punch. Over time, they grind against each other, building tension, cracking rocks like brittle twigs. Then, in unstable zones, kaboom, an earthquake erupts, shaking everything from mountains to your morning coffee. But here's the kicker, it's not just about the plates. Every fault line's a unique snowflake. Some rocks are tough as nails, shrugging off pressure like shawms. Others, total pushovers, crumbling under stress. Then there's friction and heat. Some rocks melt a little, oozing slippery fluids made of super hot minerals that grease the fault, letting it slide easier, but others stay bone dry, locking up tight, storing pressure like a ticking time bomb. Oh, and don't forget the wildcards, gravity tugging from above, and swirling currents of molten rock below, stirring the pot. It's like trying to predict a chef's next move in a kitchen full of exploding ingredients. Good luck with that. So, how do we catch these sneaky quakes? Step 1, we play detective with history. Scientists notice these plates have a rhythm, a kind of geological dance. By studying where and when quakes have hit before, they can say, hey, the San Andreas fault, it's overdue for a big one, like, any millennium now. Cool, but super vague, right? We're talking centuries-wide guesses. Not, set your alarm for Tuesday, precision. For the short-term scoop, we've got fancier tricks. Geologists use seismometers, these high-tech gadgets that listen to the Earth's tiniest whispers. Those little pre-quake rumbles. Better yet, your smartphone's in on the game. Yep, most phones can pick up primary seismic waves. The first tremors before the big shake. Imagine billions of phones linked up, forming a global quake alert squad, pings going off like, heads up, something's coming. Problem is, it's often too late to yell, duck, before the ground's already grooving. Still, that data, gold for tools like NASA's Quakesim, a brainy program crunching geological stats to spotlight danger zones. Science fiction vibes, right? But wait, there's a wilder clue hiding in plain sight. In 2011, just before a monster quake slammed Japan's east coast, researchers sniffed something odd. The air was thick with radon and thoron, radioactive gases leaking from the crust. Picture this, as pressure builds, micro cracks pop open underground, letting these gases sneak out like smoke signals. Scientists went, aha, if we blanket quake-prone spots with detectors, we might predict these beasts a whole week early. A week, that's time to evacuate, stock up, or at least brace yourself. Game changer status. Now, dream with me for a sec. What if we could X-ray the Earth? Peel back the crust, peek at those plates shifting in real time, and shout, incoming, before disaster strikes. We're talking saving tens of thousands of lives yearly, families reunited, cities spared. We're not there yet, but every tool, phones, gas detectors, NASA tech, brings us closer. For now, they help us prep fast, react smart, no vase required. Zhang Heng would be proud. So, what do you think? Earthquakes are wild, unpredictable, and a little scary, but we're hot on their trail, ready to join the chase.